Hi everyone, I'm Namit. Today I'm excited to present the progress we have made for our project, TabulaX. TabulaX is an AI-powered tool that helps automate the tabular data transformation using large language models. It's built for data engineer, analysts, and anyone working with CSV or databases who want to clean up or map the data automatically using the LLMs or the transforming the data and integrating the integration purposes. So we begin by running the front end of the backend of the website. The user can log in to the email and password that you have signed up. When they join the Google's login by waiting within the developers, then the user uploads source and target values in the relevant columns. The data is sent to the backend and the forwarded to the Android level to the review log running a RLM model. This transformation function is for first time extraction. The LLM classifies it into the four categories: stream, member, algorithm, and general. It then generates a transformation function which is sent back to the runtime and displayed to the user. User can check the transformation function firstly. If it is wrong, can edit the function. User can now either upload a file or connect to the database. That where we have the personal data. For that, we have to apply this transformation function. First, he uploads the data from his system. Transformation, where we can see the transformation upload in the children's part in the application. So then you can download the CSV file, the function package. And also you can connect to the database, MySQL local server, and the DynamoDB AWS server, AWS database, which is NoSQL database. By doing these provisions, you can connect to the MySQL database. You can select the table from the database selected and the column for the database. This is selected from this is the original table in the SQL database. Source table selected. The transformation. In the transformation, we apply down the this in this column. The input is okay. That's yeah. We got from the DynamoDB cloud database. Is connected to the AWS DynamoDB database by the credentials that are access can secretly given for the user in the AWS platform. So the table will learn column in the table. You select the column. This is the column that was displayed in the that I have created in the AWS. This is the column as I have selected the many column to transform. The values that have to be transformed in a table. And also in that column and download the CSV character transform. First, you use the demo page. The demo page is start selecting by is now source and target tables. And select the source and target for relevant columns. And those are sent to the server.js by transformation function box. Generate function from the server.js by backend server.js generate function. It's also the backend node takes the selected columns and forward them to the ngrok where the LLM is running in the Google Colab. Our Mr. LLM is hosted on the cloud server inside a Colab exposed via ngrok. The server receives the source and target values. Value classify and transform type and generate a transformation type and function by classify transformation and use both the categories of transformation type string, algorithm, numeric, and gender. If it is a string, it goes to the string transformation function. String type transformation, we classify and generate the transformation type using this right target prompting, like this with this prompt. For memory transformation, we use computing with a language mathematical diagram. This also find the strict mathematical functions to map sources to the target values. Uh, for linear polynomial cubic exponential and rational implementation of tablets, we gained deep insight that sought multiple areas like prompt engineering. We explored various prompting techniques to guide the LLM effectively, such as chain of thought prompting, encouraging the model to break down the reasoning steps, feature prompting, providing examples to improve the prediction accuracy, self-thought prompting, uh, self-thought reasoning, enabling the model to verify its outputs independently by itself. The downstream chaining tasks where LLM output feeds into the second task, land that market algorithm, using it to optimize for fitting, which helped into accuracy in numeric transformation cases. AWS cloud services. Became more handy with the AWS most important technologies like RDS and DynamoDB. RDS is for relational database like SQL and for local database, and DynamoDB like MongoDB, NoSQL database. And also hands-on with EC2 instance or cloud computing hosting, cloud compute hosting services as a root user with the IAM role and secure key access and database connectivity. Implementing MongoDB for the authentication storage connected MySQL local and also RDS for cloud database and DynamoDB also for cloud database. RDS for NoSQL and RDS for SQL. DynamoDB for NoSQL databases. Securely connect to the databases using Flask+, Water3, and PyMySQL. These are we use it for connecting to the databases. In the complex cases like algorithmic in general, we apply chain of thought prompting. We try to infer the relationship between the source and the target first before asking the LLM to generate a function. So define the relationship and generate a function for the those relationship categories. Then those are back returned to the server.js. The returns transformation type and the function code. In server.js, we receive the transformation type and the function code. In front end, we display then we apply the transformation. The code and the transformation type are get here, and the input tables that we are given are also can we apply the transformation function that code that we got from the Nginx server to the input values we have given. Of our architecture. Our architecture is available from your basic setup using DeFi and React Framework, much more reactive and powerful UI. We shifted from Google DeFi to Mr. only because it is open source, accurate, and works smoothly in the low memory environment like Scholar, which has 16 GB. We also added dynamic feature like drag and drop, power uploads, and instant transformation previews. This made the user experience more smoother. Uh, and also we kept the database retrieval we have to for the public data. And first we try with the local database, and now we are doing it the cloud databases. And so we evolved from local database to cloud database. And next, difficulties. So the major issues we faced while implementing the product, memory limits on collab. We forced us to limit input size and make it so we can't use more much bigger models. So we use only instance only with a quantized tool for which is quantized for bigger and occasional hallucination by the LLM. Misclassifying the types. It is misclassifying algorithmic and string sometimes, and numeric and algorithmic also for sometimes. Uh, by loading the more examples to it, is hallucinating. So we took more time for the examples to keep for the LLM to understand without loading it. And And the RDS free tier limits made us to switch to the local MySQL server, and we will compulsorily implement the RDS when we get main account of AWS. The major thing we have facing out main and important thing is prompt trainers. Prompting is very hectic task to do. First, we got inaccurate results. We tried and we got more accurate results later on by learning the prompting algorithms, prompting techniques. Next, I will choose Mr. Sandy. We pick the Mr. Sandy or GPT or T5 or Google models. It's because it is an open source and free to host. Fits easily to the collab with 4 GB of GPU memory. It is collab friendly model. Outperformed other models with 85% accuracy with the few-shot prompting technique and the China thought company. It gave us the right balance of performance and cost efficiency. Other models we have used are DeepSeek 6 billion. It was one option. It's open source, but it gave low accuracy around 70%, and it is also a need for more memory, which made us to run on the collab. We also tried for Google's T5 11 billion. It's also a powerful model, but it needed around 22 GB of RAM, far more than what Collab or retail cloud setups, cloud handles. It also wasn't tuned for table specific tasks. In GPT and Gemini, they are very accurate. Had another issue, API cost. GPT cost more, and Gemini has a rate limit for minute, so only 15 API, 15 calls per minute. So we finally considered Mr. Only open source naturally, and it performs more better than the other models which are in its comparative. It is also hostable, made it optimized shoes for our. We thought of doing creating a launcher in the EC2 mission on the for as of now we are just running it in the AWS environment. The product is running in the AWS environment, but the model is not running because the product is giving only 1 GB RAM. We need more RAM, so we will try further to get better AWS account. So to wrap up, TabulaX is our attempt to bring intelligence and automation to table confirmation. We believe this can save hours of manual efforts for data engineers, and we excited about its potential in real world tests. Thank you.